Alright kids, in this video we are going to talk about the area of special quadrilaterals. Okay? Now, one of the special quadrilaterals that we are going to discuss is the trapezoid. The trapezoid is a quadrilateral that has only one set of parallel lines. So here's an example of a trapezoid, and you can see that it only has this set of parallel line segments. Okay? The other line segments are not parallel, but it is a quadrilateral, so it does have four sides and four angles. Alright? You can find the area of a trapezoid by decomposing it into triangles and rectangles. Alright? So, in other words, this trapezoid can be decomposed into two triangles and one rectangle. So here's our original trapezoid. What we want to do is when we look at a trapezoid, we want to see in it different shapes that are easier to work with, such as two triangles and one rectangle. Okay, so and if you notice that from this trapezoid we've got our various shapes, like this, we'd have this triangle over here, we would have this triangle right here, and we would have this rectangle right there. And when we take it apart, what we're doing is we are setting ourselves up so that we have easier shapes to work with. Okay? Easier shapes to work with versus trying to work with all of that. That's called decomposing a shape. Alright? So how does it look mathematically when it comes to finding the area? Well, use your new polygons to determine the area of the trapezoid. So what we know is we have a rectangle inside here, and we know that we have 12 and 10 as our dimensions. Okay, so if we want to figure out the area of the rectangle for our trapezoid, we want to start with the formula for finding the area of a rectangle. And so then what we do is we find our length and our width, and so 12 is our length, 10 is our width, and we plug those into our formula, and then we do 12 times 10 to get an area of 120 square feet. So the rectangle has an area of 120 square feet. Okay? 120 square feet. Alright? And then what we'd want to do is we'd want to find the area of the triangle. So we would take the formula for the area of a triangle, which is 1/2 times base times height, and we would plug in our amounts for the triangles. So in other words, 4 is our base, so we're going to plug 4 in as our base, and 12 is our height, so we'll plug 12 in for our height. And then we simply do the math. 1/2 of 4 is 2. So 1/2 times 4 gives us 2. So now we have 2 times 12. 2 times 12 is 24. Now remember though, we have two triangles in our trapezoid. So the area of 24 square feet is not going to work because we have to double it first and get 48. So a combined measurement of 48 square feet for both triangles. Okay? And so now we know the area of our rectangle. Okay, we know the area of our rectangle, and we know the area of our two triangles as well. Alright, so what we have to do then is combine those two areas, add 120 to 48, and we get 168 square feet. So the area of our whole entire rectangle is 168 square feet. And that includes all of the triangle, and all the rectangle. Okay? So, in review, this is how you find the area of a trapezoid. Okay? We take our trapezoid and we look for shapes that are easy to find and easy to work with. In this case, we have two triangles that are going to fit perfectly into there, and once we have those triangles in place, we then establish a rectangle. Now we like to figure out the area of the rectangle first because it's just length times width, and then we figure out the area of one triangle, but we have to double it because we have two triangles. Okay? And that's how we find the area of a trapezoid. Another type of quadrilateral that we're going to want to investigate is the kite and how we find the area of a kite. All right? Kites are quadrilaterals with two pairs of adjacent sides which are equal in length. You can find the area of a kite by dividing it into two congruent triangles. You then determine the area of one triangle and then double that area. So in other words, this is our kite over here, and we see that we have our measurements set up for us. We have intersecting lines that are perpendicular, and we need to decompose it. So in order to find the area of this kite, what we want to do is we want to think of it as two separate triangles, okay? Now, when we think of our kite as two separate triangles, we now have to identify what the base will be and what the height will be. Well, naturally, in this situation, the best way to look at our triangles and their base and height would be to identify this distance all the way down here as the base, and to identify this distance as the height. Okay? So if we do that, we can say, okay, our base is going to be 5 plus 25. So our overall base is going to be 30 centimeters, okay? Because it goes from here all the way to there, and we have to add 25 plus 5 to get our base. And then our height, of course, is that line, which is indicated by 10 centimeters. So our height is going to be 10 centimeters. And sometimes it's good to just kind of orient yourself so you know what you're looking at. And then all we have to do now is we have two triangles, so we just find the area of one triangle. And when we do that, of course, we're going to use our formula of 1/2 times base times height. And so we'll plug in our numbers, our measurements, and we will have 1/2 the base, which is 30, times the height, which is 10. And as we do this, 1/2 of 30 is, of course, 15. 1/2 of 30 is 15. So now we're going to multiply that 15 times 10. And if you multiply 15 times 10, you will get 150. And so we have each half or triangle of the kite has 150 square centimeters of area. So 150 square centimeters. Now remember, we're going to have 150 for this half and 150 for that half. So our next step is to take 150 and multiply it by 2. Or you could add it. Either way, you're going to end up with an area of 300 square centimeters. And so that's how you would find the area of a kite. You simply look at your two triangles, determine the overall base, determine the height, and then use the formula for one triangle and then double it. Okay, so the steps, you find the overall length of one triangle, and then you multiply by 2 to double it for both triangles. All right? Let's try some example problems now. So what you'll want to do is take out a piece of paper, if you don't already have it out, and try solving some of these area problems on your own at this point. Let's take a look at this trapezoid. Now we call it a trapezoid because you have one set of parallel line segments and it's a four-sided figure. Why don't you pause the video and see if you can figure out the area of this trapezoid. Alright, let's see how you did here. Let's take a look. Alright, when you look at this, you can see that you clearly have one triangle and one rectangle. Okay, now some people like to do the rectangle first, and so if we look at our rectangle, we can see that we want to multiply the length times the width. So we have the area of the rectangle will be its length times its width, and when we do that, we see that our area will be 12 times 8. So if we take 12 times 8, we end up with an area, and again, that is our basic fact, we end up with an area of 96 square feet. Okay, so now we've done our rectangle. The next thing we want to do is take a look at our triangle. Well, in this case, you could just say that this is the base of our triangle and this is the height of our triangle. So when we figure out the area of our triangle, we will use our formula of 1/2 base times height, which will give us the following numbers to work with. 1/2 of 8 times 6 for the height. And so we would have 1/2 of 8, or 1/2 times 8 is 4. And then we will multiply that times our height of 6. And our area then for the triangle would be 4 times 6. So it would be 24 square feet. So now our triangle has an area of 24 square feet. So our third step and final step will be to take our area for the rectangle and our area for the triangle and add those two together. And if we add those together, we can see that 6 plus 4 is 10. Regroup. 1 plus 9 is 10. Plus 2, it gives us the 12, which gives us a total area for the entire trapezoid of 120 square feet. Take a look at this kite and see if you can solve the area for that kite. Pause the video and try solving that problem. Alright, here we go. Let's take a look at what we have here. Okay, in this situation, remember it is a kite and we wanted to make it simple and reduce the steps for figuring out the area as easily as we can. Now, in this case, what you have to realize is that we have this triangle right here that goes like that. Now, that's not exactly the prettiest triangle, but it tells us that we have one triangle like that, and it is congruent to this triangle down here. And what we need to do now is we need to establish the base distance, and we need to establish the height distance. Okay? Well, the base is going to be 11 plus 7. So the entire length of the base is going to be 7 plus 11, and 7 plus 11 is 18. So the whole base is going to be 18 centimeters. The height, okay, is half of this distance, which means it is 4 centimeters. So what we're going to do is we're going to write down those measurements. We're going to write down those measurements and make sure we use those in our formula for finding the area of one triangle, which is 1/2 times the base times the height. So if we set up to do the math, we will have 1/2 of the base of 18, so 1/2 of 18 times a height of 4. All right, so we do the math, and we take 1/2 of 18 is 9, and now we multiply 9 times 4 in order to get the overall area of 36 square centimeters. Okay, so one of these triangles has an area of 36 square centimeters, but we have two of those, so now what we have to do is we have to take 36 and we have to multiply it by 2. 36 times 2 is 72, and if you're not sure, you can take your 36 and you can multiply it by 2 on scratch paper. 2 times 6 is 12. Regroup your 1. 2 times 3 is 6 plus 1 is 7. So our answer, of course, is 72. So the overall area for this kite is 72 square centimeters. And the important thing that you wanted to remember is that you took this and you broke it up into two triangles. Now, one of the things that some of you might have actually realized is that you could have even done this a different way. Okay? You could have actually looked at this and said to yourself, okay, if I take this triangle and I combine it with this triangle down here, what I have is I'm actually going to get a rectangle that forms up for us with the following dimensions. I will actually get a rectangle that forms up with 4 by 11 dimensions, which would be 44. So you could have combined these, you could have composed them into a rectangle and then said, okay, well then opposite of that, I have these two triangles, which if I take them and I combine them together, I would get another rectangle, and it would be a rectangle that has the dimensions of 4, okay, because our height is 4, and 7. And so some of you could say to yourself, okay, 4 times 7 is 28. So this whole rectangle is 28, and then if you take 44 and you take 28 and you add those up, 4 plus 8 is 12, regroup your 1, 1 plus 4 is 5, plus 2 is 7, you'll find out that you could have composed your kite into rectangles in order to solve this problem. See if you can find the area of this trapezoid. Pause the video and see if you can come up with the answer. Okay, here we go. Let's see how you did. Now, in this case, you might want to say, I'm going to do the rectangle in here first. So if we do the rectangle first, what we would do is we would take our dimensions, and the area of a rectangle is, of course, length times width, and the numbers we're using are going to be 8 feet as our length, or you could have used 10 as your length because of the commutative property, and our width is going to be 10, which means the area of our rectangle is 80 square feet. Okay, but that is only for the rectangle. Okay, now what we have to do is figure out the area of one of the triangles. So if we want to figure out the area of the triangles, what we need to do is take our formula. Oops, got that messed up there. We take the area of our triangles and we set up our formula, which is going to be the area will equal 1/2 times the base times the height, and I'm going to write it over here where I have more room. So our area for our triangles will be, I'm just going to go with a base of 10 because it's convenient, it's right there, and then I can use 3.5 as my height. So I want to do 1/2 of 10 times the 3.5, 3 5/10 of a foot. So if I do that, 1/2 of 10 is 5. So we will be multiplying 3 5/10 by 5. And if I need to do my math over here and scratch paper, I can do that. I'm going to take my 3 5/10 and multiply it by 5. 5 times 5 is 25. Regroup the 2. 5 times 3 is 15, plus 2 is 17. So the area of one of my triangles is 17 5/10 square feet. Okay? But remember, we're not done yet. We still have to take the area of our triangle and the area of our rectangle, and we have to combine them. Now remember, we have 2 triangles, so we have to actually take our 17 5/10 and we have to double it before we add it to the rectangle. Or we could add all 3 of them together. I just find that it's easier to take the 17 5/10 and multiply it by 2 to get our overall for the triangles. 2 times 5 is 10. Regroup. 2 times 7 is 14, plus 1 is 15. Regroup. So I get a total of 35 square feet for the triangles. So I'm going to take the distance of the triangles, which is 35 square feet, and the distance of the rectangles, and I'm going to combine those together to come up with the total area of 115 square feet. And so if you came up with that answer, you got 100% on that problem. Okay, hopefully that helps you out and helps you understand how to solve the various quadrilaterals you might encounter. If you have further questions, you can see your teacher, you can use your book as a reference, or talk to your parents.